Question 6 then. We've got 44% of the students in the school are boys. So how many girls? Well, in total it's 100%. So if we take 44 away from that, then we'll get 56%, and that's our solution there. Part B, a bottle is full of water. Probably draw a bottle out actually, and 30% is poured out, so we've already lost here 30%. Half the remaining water is then poured out. What percentage is left? Well, from here we've got 100 take 30, so we've got 70% left, and then half of that is then poured out, so 35% is poured out. So what's then left? If I've taken 35% out as well, then we've got 65% taken out. So what have I then got left? Well, it's then 100. Take away our 30, take away our 35, which then leaves us with 65 taken out, so 35% is left over. Question 7. Diagram shows first part of a board game. Roll an ordinary dice. From the start, move the number of spaces shown by the dice. The circle, a word that describes the chance of landing on black on your first move. Well, black you can get from 1 to 6 on a dice. So the chances of getting a black one are when you land on a 1, a 4, or a 6. That's 3 times out of 6. Which if you divide by 3, top and bottom, will then give you a half. So there's an evens chance of getting that. Part B, circle the word that best describes, so you should have circled even, sorry. Circle the word that best describes the chance of landing on grey. Well, grey, there's absolutely none there. So the chance of actually getting a grey on the first roll is impossible. Part C, Beth starts the game. She lands on black both of the first 2 moves. Write down the 2 possible pairs of numbers she could have rolled. So if she lands on black for the first possible 2 moves, then the only way she'll do that is she could have rolled on a 4 first. That wouldn't then work at all, because if you got a 6 next, then that lands you on a 10 on the second go, so that can't work. So 1 roll could possibly be a 1, and then if she rolls a 1 first time, then what she could roll second, she could roll a 3, because then she'll land on a 4, so that's 1 possible 1. If she could have landed on a rolled a 1 and then rolled a 5, and that would have been black both times. Or she could have rolled a 6 and then she could have rolled a 5. So any 2 of those will be fine. Question 8a. Use a calculator to work out the 2 numbers in the list that are multiples of 7. So what you do actually is you divide each of these numbers. So I'll do the first one. You divide them by 7, and if you get a whole number, then that means they're in the 7 times table. So we'll work that out for the first one. And I just work through the rest of them. The second one gives me a decimal, so it won't be that one. The third one, so I'm dividing 489 divided by 7, so it won't be that. 602 divided by 7, that's 86, so that one will work. And then I always double check the last one just to make sure, and that again gives me a decimal, so it doesn't go fully. Part B, use your calculator to work out the 2 numbers that the list are factors of 1001. So we take 1001 and the factor is the number that goes into it wholly. So we divide it by 3, we divide it by 7, divide it by 9, divide it by 11, and divide it by 17. And then the numbers that go into it wholly. First one's not the case. The second one does. So we'd circle 7. The next one doesn't. Then divide it by 11. And that one does. So it appears we've got our 2, but again, just double check whether you're dividing by 17 And again, that one doesn't work, so you've got your 2 answers. Question 9a. Suppose you've had a gun to equal sections, you want to plant flowers in each section so the colours are symmetrical. Copy this diagram so that there are 4 red sections, 4 blue, and all the colours have symmetry about mirror line A. So I've got down here, just drawing out the rough grid, we've got that, and we've already got B and R in here. So complete the diagram, show that the colours have symmetry about mirror line A. So what needs to happen and what must happen, and I'll just change the colours here to say that these two have to be where they are. So B and R have to go there. And then what you need to have is you could have a B here. So one combination is a B here and then a B there. Let's put these in blue. So B there and a B there, and then an R there and an R there. Or equally, you could have different combinations. So you could have the R and the R on the top and the B on the bottom. So they're the two really. Part B is then looking at symmetry about both mirror lines. And some students struggle with this one because they thought they didn't really start struggling with the starting point. Well, if you just say R's going to go there, well, if you reflect it in this mirror line, R's got to go there. Reflect it downwards, it's got to go there. And reflect it across, it's got to go there. Then you put your B in, and that's got to go there, there, and there. Or equally, I've just put underneath, you could have the setup where you've got your 4 R's in the middle, and your B's on the outside. Question 10. 12 litres of drink is made by mixing 3 litres of orange juice. What fraction of the drink is water? So the fraction of drink that's water, well, how much of it is water? 3 litres is orange juice, so then 9 litres is what's left from 12. And that's out of a total drink. If we then divide it by 3, it's worth 2 marks, so that'll be 1 mark if you got that. Divide by 3, 3 threes going to 9, and 4 threes going to 12. So that would be a simplified version of the second mark.